right, welcome back, everybody. There's a whole lot of us here today. I'll try not to be disruptive for the rest of our classmates. Today we're going to be covering 9.6, which is algebra functions. And the hardest part in there is the domain of f of g of x as well, and that's what we're going to practice and cover today. 9.7 is inverse functions. And I think the hardest time students have in this section is actually finding inverses. So we're going to work on doing that in here too. Oh, that video is looking like shit. All blurry, sketchy. Well, not much I can do about that. So fog x really means f of g of x, which means if we have two functions, f of x and g of x, we stick g of x in f of x everywhere there's an x. For example, let's say f of x equals 3x squared plus or minus x plus 1. And we'll say g of x equals 2x plus 3. When we do f of g of x, everywhere we have an x in the original equation, we are going to replace it with g of x. So I'm going to put g of x right here, which is 2x plus 3. So I'm going to replace all the original x's with 2x plus 3. Making sure that the squares and cubes and anything that's touching them applies to the whole thing. We did this with the x plus h. Remember doing that with x plus h on our difference quotients? So we've done stuff like this before. That's old stuff. So what do we have here? If I square that, that is really 2x plus 3 times 2x plus 3. I'm going to distribute that minus real quick and have minus 2x minus 3 plus 1. So we multiply that out, we get 4x squared. This times this gets me a 6x, and that times that gets me a 6x. So together those are 12x. And 3 times 3 is 9. Then I have minus 2x, and I'm going to combine the minus 3 and plus 1. So we distribute, we get 12x squared plus 36x plus 27 minus 2x minus 2. And we finally combine them together. And my like terms are my x's. So 36 minus 2 is 34. And 27 minus 2 is 25. So when we look at the domain for these, we need the domain of g of x. And since it's a line, and it's not a horizontal line or a vertical line, the domain is negative infinity to infinity, and so is the range. When we look at the domain of f of g of x, what's happening here is after we've calculated g of x, this is actually the output from g of x, which is the range. So we gotta make sure we're restricting what can go into f. In this case, there's no restriction because the range was all numbers. But in some examples, so no restriction here. But in some examples, we have a restriction. And since there's no problem with the range is all numbers here. This is just like, it's like putting in any x, so this transitions into just the domain of f of x, since there's no restrictions. And quadratics, we can stick anything in. Our x squared functions have a domain of all real numbers. Ready to go for a little bit harder? Let's make this -2. Say x plus 4 here. Ah, fuck it, we'll leave it as x plus 2. So doing f of g of x here is actually fairly easy. There's only one x in f. And so we just take our square root and stick it in. And remember the notation for this is fog x. Okay, now let's start looking at the domain. What kind of restrictions does this have? Does the square root have in general? Any restrictions on what we can put inside of it? Like, just think about general square root of x first. We'll modify to x plus 4 in a second.
X can't be 0.
We can take to the square root of 0. Square root of 0 is fine. It can't be negative. So another way of saying it can't be negative is saying the inside needs to be greater than or equal to 0. So 0 or positive. So to find out what's allowed, we're just going to set the inside equal to that and solve. It's greater than or equal to -4. So the domain of g of x is -4 to infinity. And since we can include the -4, I need to make that a bracket.
Bracket is when you can use that number. The
Yes.
parentheses is when you can't use that.
Parentheses when you can't use the number.
So if it was like parentheses -4, you wouldn't be able to use that.
Correct. All right, so now that we have that. Now that we stuck in g of x, what kind of restrictions here?
The denominator can't be 0.
The denominator can't be 0. Bottom cannot equal 0. So let's set it equal to 0 and find out what it can equal. Maybe I do need to make that negative. Let's make that negative. Let's make this x minus 2. I knew there's a reason why I wanted to do minus. So if we solve this, we get square root of x plus 4 equals 2. If I square both sides, I get x plus 4 equals 4. And I get solve for x and I get x equals 0. That means x can't equal 0. And we have to combine it with this. Combine with the restrictions on g of x. So our overall domain of f of g of x, we have -4 up to 0. We can't include 0, but we can include everything around it, so we're going to do parentheses with 0.
Like for positive infinity, would there be a bracket or like would there ever be a scenario would it?
There's
where it would be
never a bracket for infinity, because
Never a
infinity is not a real number. It's that concept. We ever tried to pick a number for, like, give a number to it, I can always add 1 and have a higher number.
Yeah.
And the concept of infinity is it's the highest number, so. Defining it. Or trying to include it means, excluding numbers that are higher. Is that fun? No?
It's something.
Well, if it helps to let you know. There shouldn't be any problems on the test that have domain of f of g of x on it. But you do need to have seen it and know how it works. All right, onward. Let's take a look at inverse functions. And specifically finding them. It's important to note that the inverse of f of x is listed as f to the -1 of x. And that -1 looks like an exponent, but it's not. When we put it on names of functions like f of x or g of x or h of x, it means inverse. If we don't have the f of x in there and it's just some algebra expression with a -1, that's an exponent. So to find the inverse of a function, step one, set f of x equal to y. So like if we had f of x equals 2x plus 1, we're gonna in this step say y equals 2x plus 1. Step two, swap x and y. Everywhere you see a y, put an x, and everywhere you see an x, put a y. Step three, solve for the new y. So if I did this, I would subtract 1 from both sides, and I have x minus 1 equals 2y. And then I divide by 2. And I get x minus 1 over 2, or which is 1/2 x minus 1/2. That equals y. Whichever one we want to use. Step 4, replace y with f inverse. Let me let you guys try one that's not too bad. Try f of x equals x squared minus 1. Give you one more minute, we'll do it together. Or a couple more minutes, I guess there's only 4 of you, I have to wait till you're all finished. Alex does have some neat stuff, it has some snitch on your students shit. It'll like, you can set like how many days you want as like a you're late kind of thing, you haven't done, you showed, done any homework. And like the default 7 days for, so any student that hasn't logged in at all. For 7 days, it like makes a list, every time I log in, it shows me. And I logged in last time, there's like 66 students total and like 26 were on the list. And I get with the 4-day weekend, that, but. Of the 26, like 16 of them were like more than 2 weeks. Some like 16, I forget how many. Some are like mid-January, late January, like basically a week and a half after the class started. They logged in once, they stopped doing their homework. It even gives me a link to email them. So I emailed them at like 10, I emailed all the ones that are a couple weeks late. And no one said anything back. Everyone ready? All right, walk me through this. What should we do?
You have to set f of x equal to y. Then you have to swap all the x's for y's and all the y's for x's.
So what should I write down here?
X equal y squared minus 1.
Okay,
Solve for the y. Add 1. Then would you square root?
take the square root.
It'd be y equals root x plus 1. And then you replace y with the inverse of f of x.
That's it. So if we graph. Oh, let me do that on Desmos. Let me hide that one because we're gonna do that one later. So we had f of x equals x squared minus 1. So it looks like the domain is all real numbers and the range is -1 to infinity, right? What happens when we look at, I'm gonna say g of x. We have square root, and we had x plus 1, right? I turn off that. Now our domain is -1 to infinity. And our range is just 0 to infinity. So I'm gonna write that down real quick. So on this one, we start off with d was -infinity to infinity. And r was -1 to infinity. Over here, we see d is -1 to infinity. And r is just 0 to infinity. It looks like the range here became the domain of this one. Right? Does that make sense? We swapped all our y's and our x's. And y is all our outputs, so y is the range. So everything that y could have been was the range, and we replaced it with x. So like all those numbers that were y are now x, and x goes with the domain. So everything that was the range became the domain. These two don't match up though. These two should have switched also. Functions that have inverses need to be 1 to 1, and this one was not 1 to 1. We'll talk about 1 to 1 in the main course. The way we can do that though is restrict the domain here. We could say d is 0 to infinity and include 0. We were able to include 0. We were able to include -1 too, so. So can I do that on here? Can't. Let me so let's come back over to Desmos and look at it real quick. So that's what we had. And if I restrict it to being greater than 0, I have that. Just the right side of the function. And now if we look at the inverse, it looks like that. We look at, put the y equals x line in there. Doesn't it look like the y equals x is like perfectly dividing it? The overall picture, like one is a reflection of the other over y equals x. That's how inverses are going to work. Always, all inverses will have this reflection because the x's and y's swap. We said we did that, so like the same premise holds for me doing an x and y table. If I were to do an x and y table for f of x, when I swap, I could just relabel it for f of inverse y and x. All the values swap. And you get that nice little mirror property. Was this too bad? I didn't think this one was gonna be too bad. The next one, students tend to grumble about. All right, let's find F inverse here. And we're gonna look at the domain and range of both in a second. So I'll look at the domain of f of x right here. We can't have the bottom can't equal 0. So 2x minus 1 can't equal 0. X cannot equal 1/2. So the domain is negative infinity to 1/2 in union with 1/2 to infinity. That should be our new range. Not as easy, is it? Hopefully everyone made it there. Because all I did was swap x and y at that point. Lauren's giggling. Lauren did make it there. Okay. You got stuck there though, didn't you?
Yeah.
Anyone else get stuck there? This is a natural I got stuck spot. So, what does Jones say to fractions? Fuck fractions. That doesn't go away. It's universal. How do we tell fractions to fuck off? What do we do when there was just like a number down bottom? We multiply by it, right? Let's do that. Let's multiply both sides by 2y minus 1. And students still get stuck here.
They got there and got stuck.
What can I do? I can distribute. Doesn't look like a lot of other things we can do. Now. Seems reasonable.
Do you divide by x?
Not just x.
X, y?
No, not by y. We want to keep y alone.
Keep y, 2x.
2x. And now we stick our f inverse in.
X plus 3 over 2x, it doesn't simplify anything.
We can break it up. We can break it up into x over 2x plus 3 over 2x. And that would simplify to 1/2 plus 3 over 2x. Whether you want to do that or not is up to you. This is probably how I would find the domain and the range. So when we have like f of x equals like 1 over x, the graph looks like this. Where just x can't equal 0 and y can't equal 0. We've seen that before. By doing the 2x minus 1, it shifts it over so that the vertical asymptote that is right here. When we do the 3 over 2x minus 1, it shifts it over to x equals 1/2. Is where that vertical asymptote is. So we would have this. Domain still has the same problem though. So x can't equal 1/2 in our f of x, and range y can't equal 0. So when we swap them, so this is for the 3 over 2x minus 1. When we do the swap for inverse, we have y can't equal 1/2 and x can't equal 0. Does this make sense with what we see right here?
Where'd you get 3 over 2x minus 1?
What we started with? So that was our f of x up above. And so this stuff is for f inverse of x. Can I see that x can't equal 0 in this inverse function? So does this match with this? Can I stick x equals 0 in? No. So that tracks. What about y can't equal 1/2? So like the way of seeing that, what can't y equal? Like if y equals 1/2, if y equals 1/2, I have 1/2 equals 1/2 plus 3 over 2x. And if I subtract 1/2 from both sides, I get 0 equals 3 over 2x. Is there any way to get 0 out of this? No, zeros can only come from the denominator there. So there's no way to get a 0. So that implies y can't equal 1/2. A little bit harder to find and identify that y not equaling 1/2. Even starting with this. Right? Like if I just look at this and don't have any more information, I'm not sure how I'd get to the y can't equal 1/2. But here it was the domain. The 3/2x minus 1. There, it's the domain. If I stick in x equals 1/2. Why can't it just be the line? Why you gotta capitalize it? Make that a little asymptote real quick. We can see x can't equal 1/2. And what do we get for f inverse? Will it allow me to do f inverse? We'll write it like that. What did we get? We got x plus 3 divided by 2x. So let me turn off this other one. And now I'll stick in y equals 1/2. And we see that's the asymptote there. The graphs kind of look the same. These two functions have very similar looking graphs. They just look shifted a little bit, right? They look moved around a little bit, but that's about it. Huh. All right, I'm gonna get even harder. Not too much harder. What can I do here? Let's see. How can I make this truly memorable? It's some wicked ass shit. Just to practice your algebra skills. Dirty. This problem is way harder than anything that would appear on a test. Okay.
Oh, I'm sorry, I'm not this full.
You waved. I saw it.
I didn't understand these.
That's good because we're lecturing on it today.
Okay.
The homework should have just been available like at 2 o'clock. You shouldn't have been able to start working on these. And
No, I think they started these ones. Oh, maybe not with the square on the bottom, but we had to find like the domain of it
oh, we did that before, yeah.
with the unions and stuff. That really messed me up. I don't know.
Yeah, we did do that before. You can't see what we're doing just by this picture alone. It's not being helpful. They are finding the inverse. Did everyone get to the buck fraction stage? I don't even know if I made this doable, I just fucking made shit up. We'll find out in a second. Oh, that should be a Y. So we say buck fractions, we'll multiply through by it. Oh, I don't know that I did. I think adding in the square fucked it up. Let's take the square out. Cause I'm trying to teach something here, they're like, this is like, if I were to try to go through with this, I would get all the Y's on one side.
Oh, I'm trying to-
And this looks like AY squared plus BY plus C equals 0. And we would have to do like quadratic shit, we haven't really covered quadratic formula yet in here. And I don't even like it, so like, let's go back to no square part. So I'm gonna like change the original function to just be 2x over 3x plus 1. So that y equals 2x over 3x plus 4. And then we swap them. And then we tell our fractions to fuck off. Everyone good with that so far?
Where'd your 2x go? Like, why is it?
I swapped the y and the x. That's part you missed the other part of the lecture. We're gonna do this in this afternoon. So we want to get y's by itself, so we need to get all the y's on one side. We can distribute at the same time. So I'm going to distribute, get 3xy plus 4x, and I'm going to move that y over by subtracting it from this side. And I can move the 4x to the other side by subtracting it. How can I get y by itself here? This is the other spot students tend to get stuck at. They forget one of the most basic things they learned in algebra. There's a y in both of these, so we can factor the y out. And we could do it when y was squared, but we can do it now that y isn't squared. And then to get y by itself, divide by 3x minus 2. So we get y equals negative 4x over 3x minus 2. I can get rid of that negative on top if I want to by making this 2 minus 3x. And that'll be our inverse. Either one of those forms. Any questions? And then again, if you walked in the last couple minutes, you didn't see the rest of the lecture goes with it, but we will be doing